The National Communications Network, in collaboration with the National Center for Resource Development and the Ministry of Education, presents CXC in Focus, a focus on the key subject areas of mathematics and English for students preparing to write the exams.
Welcome to another program in the series CXC Mathematics in Focus. We are at lesson 15. We are moving away from consumer arithmetic back to algebra. This time we are dealing with linear graphs. In this lesson, we will draw graphs of linear functions. The graphs of all linear functions are straight lines. In order to draw the graph of a linear function, we have to make y the subject of the linear equation and substitute appropriate values for x to find the corresponding values of y. The x values are the independent variable and the y values are the dependent variable. Let us apply this to an example. Consider the linear function 2x plus y is equal to 10. We make y the subject of the equation, and this can be written as y is equal to 10 minus 2x. We can assign values to x and calculate the corresponding values for y as is shown in the table. We have the values given to x as minus 2, minus 1, 0, 1, 2. When minus 2 is substituted in the equation, y is equal to 10 minus 2x. Corresponding to minus 2, we have 14. When negative 1 is substituted in y is equal to 10 minus 2x, we have a y value of 12. When 0 is substituted, we have 10. When 1 is substituted, we have 8. When 2 is substituted, we have 6. Plotting the points on the graph paper, where we have 0 on the x-axis, we go 10 units up. Where we have 1, we go 8 units up. Where we have 2, we go 6 units up. We can extend the graph to the left. Where we have negative 1, go 12 units up, but our graph, the space is not adequate to cover that. And when there's minus 2, we go 14 units up. The graph that is drawn by joining those points will be the graph of the equation y is equal to 10 minus 2x. Notice that the coefficient of x is what we call the gradient of the linear function. In this case, the gradient is minus 2. When the gradient is negative, and when you do other examples, you will recognize that. When the gradient is negative, this graph is sloped, as you see there, slope from the top left to the bottom right. There are other cases when the gradient is positive, it will slope the other way, that is the top right sloping down to the bottom left. Let's look at another equation. Y is equal to 10 plus 2x. We have the values for x as minus 2, minus 1, 0, 1, 2, and corresponding y values as calculated. That is, when you substitute negative 2 into the equation, y is equal to 10 plus 2x, we'll have y equal to 6. When negative 1 is substituted, we have 8. When 0 is substituted, we have 10. When 1 is substituted, we have 12. When 2 is substituted, we have 14. Joining those points when plotted on the graph will give us the straight line seen sloping down from top right to bottom left, the equation being y is equal to 10 plus 2x. Note the coefficient of x. The coefficient of x is 2x. Sorry, the coefficient of x is 2. Hence, the gradient is 2, positive 2. So when the gradient is positive, you have an idea now how the graph is sloping. So you know by just observation whether the graph is along the correct line or not. Now, let's draw the graph of the very two equations we had earlier. That is, y is equal to 10 minus 2x and y is equal to 10 plus 2x. Both graphs on the same line using the same table values given for x. These are values obtained earlier when we were drawing the graphs separately. You will recognize that the two graphs intersect at a point on the y-axis, at a point 10 units above the x-axis. So if we are asked to solve two equations, 2x plus y equal to 10, which is the same as y is equal to 10 minus 2x, and the other equation minus 2x plus y equal to 10, which is the same as y is equal to 10 plus 2x. If we draw the graphs, from the graphs we can read off the solution to the pair of simultaneous equations. From the graph, the solution is at the point of intersection of the two graphs. The graphs intersect at the point 0 and 10. X is 0, y is 10. So when you solve the pair of simultaneous equations algebraically or graphically, you will have x is equal to 0, y is equal to 10. Here is your problem for today. Use the graphical method in solving. You're asked to solve the following pair of simultaneous equations: 2x plus 3y equal 18 and x plus 5y is equal to 23. This question is taken from CXC January 2004. Now here is the solution to the problem given in the last lesson. This is calculating the value of P and Q and then the value of the taxi. Looking at the table, to find P, we have to find 12% of 40,000, and that answer is subtracted from 40,000, and you have P is equal to 35,200. Or you could have worked it another way. When we purchase for 100%. If there is a depreciation of 12%, then the car is valued at 88%. So if we find 88% of $40,000, we'll get the same answer, $35,200 for P. The private car now. You're asked to calculate the value of Q. The initial value is $25,000. The value after 1 year is $21,250. You subtract $21,250 from the initial value, $25,000. That answer is calculated by putting that difference over $25,000 and multiply by 100. That will give us 15% as the value for Q. The value of the car after 2 years is equal to 15% of $21,250. That is 85%, representing the 15% depreciation. And when 85% is calculated from $21,250, we have an answer $18,062.50. This brings us to the end of today's program, CXC Mathematics in Focus.
We have so far examined a number of elements you are required to know to have a good understanding of the short story. In this lesson, we are going to look at the most critical ingredients of the English A Paper 2, the use of effective language. There are several areas we must be familiar with and attempt to master the skills involved in writing effective language. We will also look at the rubric. All CSEC English A examination papers have the following. Section 3, suggested time, 45 minutes. Your answer in this section should be approximately 400 to 450 words in length. You must write in standard English. However, dialect may be used in conversation. The first thing to note is that your time is limited. You are required to select, plan, and write a successful short story in about 45 minutes. This is not an easy task, and you must, between now and the examination date, try to practice writing short stories within the stipulated time. It is advisable that you finish your story 5 or 8 minutes before the suggested time. This would give you the opportunity to reread your story and make necessary adjustments and corrections that you deem necessary. Some students make the mistake of spending so much time on the story that they have little time to complete other sections and so rush through the paper. This is not advisable. Time management is essential, so practice it. Secondly, you are required to answer one question in this section. This might appear very obvious to most of us, but it is a fact that we often get examination responses in which all 3 questions are answered, and sometimes 2. Choose carefully the question you want to answer. Plan with care and write your story intelligently. Your short story is required to be between 400 and 450 words in length. It is amazing and often disappointing that students write short stories that are 800 to 1,000 words long. While nothing is wrong with a short story of this length if written in your spare time, it is a serious blunder at CSEC. 2 things are likely to happen. 1, you do not have enough time to finish the other sections of the paper, and 2, you lose control of the story. We often find in students' short stories, either in the margin or the end of certain lines, numbers written. This indicates to us that students make a constant check of the number of words they have used at a particular juncture of the story. Clearly, this is a waste of time. As a student, you must have an idea of the number of words that you would normally write in a line. If your average number of words in a line is 8, you need to write a story of between 50 and 60 lines, or about 2.5 pages long. Often, 2 pages would give you the required number of words. Why then should you write a story that is 5 pages long? You're required to write in standard English. You must remember that this is an examination that tests your ability in the use of the English language. Incorrect grammar, confused diction, and awkward syntax are things to be avoided. In subsequent lessons, we will look more in detail at correct usage. License is given in the short story to use dialect, but only in conversation. While some of us are accustomed to speaking dialect or Creolese at home, it is absolutely necessary that the actual narrative of the short story be written in standard English. Sometimes students get the impression that dialogue must be used in the story, and therefore in the dialogue they use Creolese or dialect. This is not really so. This impression causes students to use dialogue in a contrived or artificial way. This is to be avoided. If you use dialogue and in the process you use dialect or Creolese, please remember that the dialogue should move the story along or reveal character. Having looked at the rubric or the instructions, we need to pay special attention to a number of areas in the effective use of language. Of course, these areas will be covered in much more detail when we come to look at the mechanics of writing in subsequent lessons. But for now, pay close attention to the following with respect to the short story. Spelling. As a fifth form student, you are required to spell words correctly. CXC does not make a distinction between American and British spelling. Therefore, both CENTRE and CENTER, PROGRAMME and PROGRAM are accepted. But it is unacceptable for you to use the following spelling: TUFF, CUBBERD, VECHICLE, ABANDUNT, SWIFF, SENE, RONDIVOO, INTRESTING, OCCASSION, SKILLFULL, CARCHOLIC. Homophones. It is unacceptable to use the following: PAIR for PIER. And this one is common: THERE for THEIR. HEIR for HAIR. THYME for TIME. WANDER for WAONDER. TAUGHT for CHOUGHT. FOWL for FOUL. COMPLIMENT for COMPLEMENT. And then there is confused diction. It is unacceptable to use the following: thought for thorough, interested for interesting, aggravate for irritate, many for much, less for fewer. Big words. As far as possible, use simple words. You are not on a mission to impress anyone. Use simple words creatively. Punctuation. Use such marks with caution. Concord. Ensure that the subject-verb agreement is accurate. Syntax. Avoid awkward constructions. Avoid slang, colloquialisms, and obscenities. Please note that the several aspects of correct use of language will be dealt with in subsequent lessons. A short story is easy to write, but first you need to read many such stories. You need to plan carefully. You need to be aware of the various elements or ingredients, and you need to tell your story in an interesting and creative way using error-free language. Having examined the various elements of a good short story, it would be wise for you to understand the things that CXC looks forward to in the short story with respect to their criteria. Previously, the short story carried 25 marks. From June 2006, this aspect is awarded 35 marks. Please follow closely the explanation of the criteria. English A Paper 2, General Proficiency, Specimen Paper Mark Scheme. Question 4 to 6, Alternatives, 35 marks. Expression C, 25 marks. The following criteria will be used to assess the story. A. Content and relevance of story. Storyline or the plot. Clear development of storyline. Examples: the events in the story must be linked appropriately. Must maintain links appropriate to the choice of technique. Conflict or conflicts must be satisfactorily resolved. Action must be satisfactorily concluded. Actions or events must be clearly motivated. For example, there must be some plausible reason or reasons for the things that happen. Setting must be established. There must be a clear indication of where and when the action takes place. So boys and girls, until the next lesson, I'm Ingrid Fong saying good night on behalf of the team, Bibi Ali, Parmeshwar Lal, and Ron Chichester.
The National Communications Network, in collaboration with the National Center for Resource Development and the Ministry of Education, present CXC in Focus, a focus on the key subject areas of mathematics and English for students preparing to write the exams.
Welcome to another program, CXC Mathematics in Focus. We are at lesson number 16. In today's lesson, we'll look at graphical solutions to quadratic equations. In this lesson, we will solve quadratic equations using the graphical method. if we have to draw the graph of the function y is equal to x squared minus 1, first we have to prepare a table of values. The values are then plotted on a graph paper, and the points are connected by a smooth curve. The table of values are given here. For x, we selected the values -4, -2, 0, 2, 4. To find the value for the function y is equal to x squared minus 1, note that that is y. Change the x to y equal x squared minus 1. We'll have corresponding values. 15, for -2, we'll have 3. For 0, we have -1, then 3, then 15. Plotting the points and drawing the graph will give us what we see here, this graphical representation. Notice the smoothness of the curve. We are asked to find the value for x given that the function is equal to 0. We'll look at the point where the graph cuts the x-axis. We'll recognize that the graph cuts the x-axis at 2 points, at x equal to -1 and x equal to 1. So the solution to the quadratic equation is x is equal to -1 or x equal 1. Notice the maximum point or minimum point in any quadratic equation. In this case, this is a quadratic function with a minimum point, and notice where it is located. It is at a turning point going up. It is just below 0, where an arrow is showing the point. Let us solve the quadratic equation y is equal to 1 minus x squared. Solving the quadratic equation would mean that we'll make y equal to 0. Again, we keep the same value selected for x. X equal -4, -2, 0, 2, 4. Y is equal to 1 minus x squared. When the x values are substituted in the function y equal to 1 minus x squared, we will have for -4, we'll have -15. For -2, we'll have -3. For 0, we'll have 1. For 2, we'll have -3. And for 4, -15. If we compare this table to the first one, and notice the difference in the y values, the signs are all reversed. Plotting the points and drawing a smooth curve connecting them will produce like the first one, but in an upturned manner, as can be seen in the following diagram. Notice that the curve turns upside down compared with the first one. In this case, this function will have a maximum value as indicated at the turning point there, marked max. The graph cuts the x-axis at 2 points. You'll recognize on the right that it cuts the x-axis at x equal 1, and on the left it cuts the x-axis at x equal to -1. The solution to the quadratic equation would be x equal to -1, x equal to 1. Notice the y-axis. That is called the axis of symmetry, and the equation for that is x equals 0. Because if we fold the graph paper along the y-axis, you would find that the right-hand portion of the graph will fall exactly on the left-hand portion of the graph. Hence, the y-axis is called the axis of symmetry, or sometimes we say the mirror line. Here's a problem from CXC January 2000. Given that y is equal to 2x squared minus 9x plus 4, copy and complete the table below. You are given x values -2, -1, 0, 2, 4, 6, and some of the y values are calculated. For -2, you are given that y is 30. For x equals 0, you are given y is equal to 4. For x equals 4, you are given y equals 0. For x equal to 6, you are given y is equal to 22. Now, you are required to find two values. Then the second part of the question, you are asked to draw the graph of y is equal to 2x squared minus 9x plus 4. And then in the third part, you are asked to use your graph to solve the equation 2x squared minus 9x plus 4 is equal to 15. Here is the values calculated, the two missing values. When x is equal to -1, the calculated value for y is 15. When x is equal to 2, the calculated value for y is -6. When those points are plotted and are joined by a smooth curve, we'll have the quadratic function curve, as you notice there. Notice that there is a minimum value for this curve. You look at the turning point at the bottom there, and y is equal to 15 is a straight line at a point 15 units above the x-axis, and you see it's labeled here, y is equal to 15. So that is a graph of y is equal to 15. The two graphs intersect, and notice the x value at the point of intersection. The one x value is on the negative side, that is x equal -1, and one on the right hand side, x is equal to 5.5. When the quadratic equation is solved, graphically, these are the two values that will satisfy the equation. X is equal to -1, and x is equal to 5.5. And when you are required to solve graphically, there must be some indication, some marking to show that your values are read from the graph. Here's your problem for today. It is from CXC June 2003. Use the graph to determine, and on the next slide, you will see the graph that was presented in the exam paper. A, the value of f of x when x is equal to 2. B, the value of f of x when x is equal to 1.5. C, the value of x for which f of x is 0. D, the minimum value of f of x. E, the value of x at which f of x is a minimum. F, the solution of the equation x squared minus 3x minus 3 is equal to 5. G, the interval on the domain for which f of x is less than -3. This is the graph of x squared minus 3x minus 3. Notice the minimum point. Notice where the graph cuts the x-axis, and to read that as the solution. Here is a problem given in the last lesson. Solve the pair of simultaneous equation 2x plus 3y equal 18, x plus 5y equal 23. This is taken from CXC January 2004. Here is the solution. You will recognize that both lines are straight, so the graph of the two graphs are linear graphs, and hence the one at the top, 2x plus 3y equal 18, is the first linear function. The second one is x plus 5y equal 23. Where the two graphs intersect would be the solution to the equation, the pair of simultaneous equation. And when we solve simultaneous equation, we'll have two values for the two variables. In this case, the variables are x and y. The point of intersection there would be x is equal to 3 and y is equal to 4. If these values are substituted in the equation, the left-hand side of the equation will be equal to the right-hand side of the equation. This brings us to the end of today's program, CXC Mathematics in Focus. On behalf of the production team, Rajwanti Permal, Peter Wintz, and Joseph Mackenzie, let me invite you to join us tomorrow for another program, CXC Mathematics in Focus.
We will continue looking at the criteria for judging the short story. Characterization. Characters must be believable. Example, characters must act and use language that is consistent with whom they are. Any change in character, example, personality or behavior, must be clearly established. Characters must be rounded, well developed. Dialogue, when used, should be functional. Example, may develop character, action, and atmosphere. Organization, reflecting attention to detail and event or events. Selection of details or events must be appropriate, relevant, interesting, and fresh. Details or events must be logically and effectively sequenced. Effective use of language. Appropriate choice of words to create characters, atmosphere, and setting. Economic and lively use of language to create story elements listed under A and B. Questions 4 to 6, alternatives, continued. 35 marks. Correct use of structures of the language. Sentences must be complete. For example, subordinate clauses chosen must be of the appropriate type. Sentences must be clear. Sentences must be meaningful. There must be effective and appropriate transitions between sentences and paragraphs. Subjects and verbs must agree. Pronouns must agree with their antecedents. There must be consistency in the use of tense. Accuracy of mechanics. Correct spelling, punctuation. For example, use of capitals, full stops, question marks. Paragraphing is essential. The following grid should be used in assessment. Superiority, 6. For one to demonstrate superiority, one must have excellent manipulation of features of action, structure, and characterization, excellent organization, excellent, effective, and error-free use of language. 33 to 35 marks could be awarded. For suggesting superiority, a candidate must have a high level of ability in the manipulation of features of action, structure, and characterization. Organization, excellent use of language, though there may be the occasional lapse in accuracy, and 29 to 32 marks may be awarded here. Demonstrating competence, a candidate must have a high degree of efficiency in the manipulation of features of action structure, but with some unevenness in the presentation of these features. Good organization, effective and accurate use of language, though there may be a few lapses. And here the candidate can score 13 to 28 marks. For suggesting competence, you may have inconsistency in the manipulation of features of action structure, some ability to organize events and details, some ability to use language accurately and effectively. 11 to 17 marks may be awarded in this section. Then there is incompetence. Suggesting incompetence, an inability to manipulate vital features of action structure, an inability to organize events and